Lesson 3, Compound Interest, Part 2. So we can use compound interest to look for different terms. It doesn't have to be for the future value. We can also find the principal, the rate, and how many t terms. So for example 1, we're going to isolate the formula and show how the formula can be manipulated. You can remember these formulas for future reference, or this is just a way to show you that any formula can be manipulated, and this is how it's done. So first, if we were to isolate P, we have A is equal to P 1 plus R over N to the power of NT. To get P by itself, we divide by 1 plus R over N to the NT on both sides. This will cancel this, so A over 1 plus R over N NT is equal to our principal value. So that's the easiest one to isolate. The rate isn't that bad, so we start with A is equal to P 1 plus R over N to the NT. So because the rate is inside the brackets, we are going to have to use square roots. So we're going to divide both sides by P first, so that this is cancelled. So what we're doing is we're isolating the one that is raised to a power. Now what we're going to do is we're going to take whatever root that is, whatever n times t is, that's the root we have to take. So we have nt, the ntth root of a over p is equal to 1 plus r over n. Now we're going to subtract by 1 and times by n on both sides. So this turns into n on the outside. We have to subtract the 1 first. The nth term of a over p minus 1. So that is how you isolate for the rate. And the last one is the most difficult. You have to use logarithms because we are solving for the exponent. But it's not that bad. We've done it before. So we're going to divide by p first. We want to isolate our exponent. So we have 1 plus r over n to the nt. Now we're going to take the natural logarithm of both sides. So we have ln of a over p is equal to ln of 1 plus r over n to the nt. Now we can always rewrite this as the exponent first, ln 1 plus r over n. So now it's no longer an exponent, rt. And we want to get rid of the n and the logarithm of 1 plus r over n. So this will cancel and this will cancel, and we'll be left with just t. So we're dividing both sides by n logarithm of 1 plus r over n. So the way it's simplified is you take the natural logarithm of your future value divided by your principal, divided by your number of compounding terms, times the natural logarithm of 1 plus r over n. And that will find your t. So again, you can remember these formulas, or you can just remember how to solve for each of those terms. So example 2, your principal is $10,000. Your rate is 3%, so 0.03. It's compounded quarterly, so our n is 4. For 5 years, so t is 5. To build a future value, so A, of $11,611.84. So we're going to show with the formulas how to get each of these numbers. So first we're going to start with solving for A. So this is just like what we've been doing. We have A is equal. Now, something that's important for us to figure out is let's just figure out what 1 plus r over n is, because we're going to use it a couple times. So this is the same as 1 plus 0.03 divided by 4, which turns out to be 1.0075. So let's just keep that in mind. Also, nt is 4 times 5, which is 20. Alright, so we have 10,000 times 1.0075 to the power of 20, and you should get $11,611.84. So that works to find the future value. Now we're going to find the principal. So we're going to substitute everything in except for p. So we have 611.84 is equal to p 1 plus 0.03 over 4 to the power of 4 times 5. So we have $11,611.84 is equal to p times 1.0075 to the power of 20. We're going to divide by 1.0075 to the power of 20 on both sides. And it's best to move everything first and then type it into your calculator so you're not rounding. So that is what you're typing in right here. And you should get $99,999.9987775 for our principal, which is rounded to be $10,000. And the reason why it doesn't come out to 10,000 on the dot is that this principal value is rounded. Okay, now we're going to find the rate. Something that you should keep in mind, just a calculator thing. If you wanted to take the nth root of something, this is the same as x to the power of 1 over n. I put 2. You can take any radical and write it as an exponent. So if you had 20 square root of x, it'd be x to the power of 1 over 20, or x to the power of 0.05. They're the same thing. So that's a calculator thing that's a little handy for you to know. So we're going to solve for the rate now. So we have $11,611.84 is equal to 10,000 times 1 plus, we don't know the r, we know it's compounded quarterly, and that we will be paid 20 times. So now we're going to divide by 10,000. And this, because it's a 10,000, it turns into 1.161184. 1 plus r over 4 to the power of 20. So to get rid of the square root of 20, or the square of 20, we have to take the root of 20. So this is where it comes in handy. I find it easier to type to the power of 0.05 into my calculator than to find the 20th root of something. So you could type 1.161184 yx 0.05. And that would be useful. Okay, but we're not going to do that yet. We're going to leave it as the 20th root of 1.161184. And this turns into 1 plus r over 4. Then we're going to minus 1, and then times the whole thing by 4. So you should have 4 times the 20th root of 1.161184, subtract 1 is equal to r. So pause the video, type that into your calculator. You should get r to equal 0.02999, and it goes on and on for a bit, which is 3.0%. And the last one, we have $11,611.84 is equal to the principal, which is $10,000, times 1 plus the rate over its compounded quarterly to the power of 4t. We're looking for the t value. So we're going to divide by 10,000. So we have 1.161184 is equal to 1 plus, or 1 point, we can simplify that, 1.0075 to the power of 4t. Now we're going to take the natural logarithm of both sides. So we have the natural logarithm of 1.161184 is equal. We know we can move the 4t to the bottom, so 4t natural logarithm of 1.0075. We're going to divide by 4 and the natural logarithm of 1.0075 so that this cancels and the 4 cancels. So this is what you're typing into your calculator, and to get t, you should get 4.999 years, which is 5, which is what we were looking for. So that is how you would manipulate each of those formulas. Alright, Ginny is 18 years old, and she wants to invest money that she can buy a home when she's 30 and married to Harry. She estimates that she will need $170,000. So that's our future value. She wants it to be $170,000. How much would she have to invest now at 6.5% compounded annually? So her rate is 0.065. The compounding annually means that n is 1. Term, she's 18 now, she's going to be 30, which is 12 years, and we're looking for P. So we have 170,000 is equal to P, 1 plus 0.065 over 1 to the power of 12 times 1. So we have 170,000 is equal to P times 1.065 to the power of 12. Divide by 1.065 to the power of 12 on both sides. This will cancel. Type that both into your calculator right here, and you should get $79,846.09. So that's how much she would have to invest now to get to $170,000. Alright, you want to save $40,000 in 3 years. So our A is 4, our term is 3 years. You're investing at an interest rate of 9.6%, which is 0.096, and it's compounded quarterly. So our N is 4. How much should we invest now? We don't know P. So same thing as last example. We have 40,000 is equal to P, 1 plus 0.096 divided by 4, divided by 4 times 3. So remember, we have to change it from an annual rate to a quarterly rate, and we're paid 4 times for 3 years. So we have 40,000 is equal to P times 1.024 to the power of 4 times 3, which is 12. Divide by both sides on 1.024 to the power of 12. This will cancel this. And when you type this into your calculator, 40,000 divided by 1.024 yx12, you get $30,092.66. So for B, how much interest do you earn? So in the end, we have $40,000. We invested $30,092.66. So that means you earn $9,907. Oh my gosh. $7.34, which is pretty good for 3 years. 3 years interest, you make almost $10,000. Not even doing anything. And for the last example, a parent has invested $15,500, so that's our principal, in a registered education savings plan, so an RESP, which is what people often do for children or grandchildren. And they want it to grow to $50,000 by the time their child goes to university in 18 years. So A is 50,000, T is 18. What is the interest rate if it's compounded annually? So N is 1. And what would it be, the rate need to be to get to the 50,000? So we're looking for R. So we have 50,000 is equal to 15,500 times 1 plus, we don't know R. We do know it needs to be annually to the power of 1 times 18. So just to simplify that, it's 50,000 is equal to 15,500, 1 plus R to the power of 18. We don't need the ones. So we're going to divide by 15,500. We're just going to leave it like that because it doesn't come to a perfect decimal. Now we have to take that number to the root of 18, the 18th root. So we have the 18th root of 50,000 over 15,500 is equal to 1 plus R, and then we have to minus 1, and we're done. So we take the 18th root of 50,000 divided by 15,500 minus 1, and you should get R. And the way that I would type it in is I would go 50,000 divided by 15,500 equals YX bracket 1 divided by 18 equals minus 1 equals. There's lots of different ways you can type in your calculator, but that is just how I would naturally do it. And you should get 0.067 to be your rate, so 6.7%.